I'm Anil Kumar, and in this video on transformation of polynomials, we'll understand how to find the image points. The question is, the function y equals to x to the power of 4 has undergone the following set of transformations. If y equals to x to the power of 4 pass through minus 216, find the coordinates of the transformed image point on the curves resulting from transformation. The transformation is vertically stretched by a factor of 3, reflected on y-axis, horizontally stretched by a factor of 2, translated 1 unit left and 2 units up. So in this particular question, we are given a coordinate point minus 216 on the graph of y equals to x to the power of 4. Minus 2 to the power of 4 is indeed 16. So this point lies on the graph of this given function. We need to find coordinates of the image point of this after this transformation, correct? So that is the transformation. Let us see how to solve such a question. So basically, we are given some original points, let's say x, y, on the graph, and these get transformed. Now when they get transformed, x and y values will change. Let us see how they really change. It depends on this transformation, right? So let's take up one by one. Vertically stretched by a factor of 3. So when we say vertically stretched by a factor of 3, that means the y value gets multiplied by 3. So we get this 3 here. Okay, so 3 times the original y value, that is what it is, right? And then it says reflected on y-axis. So when we say reflected on y-axis, that means the y value becomes negative, right? So it is reflected on y-axis. Oh, sorry, reflected on y-axis is for the horizontal. So if it is reflected on y-axis, x value becomes negative. So let me write negative for x0. Okay, reflected on y-axis, not x. Then we have horizontally stretched by a factor of 2. Horizontally stretched by a factor of 2. That means the x value gets multiplied by 2, right? So it becomes 2 times. Horizontally stretched by a factor of 2. Now let's look into the other transformation, which is translated 1 unit left. So left is also horizontal, translated 1 unit left. So when you move left, you do minus 1, correct? And 2 units up, so we say 2 units up, that will change the y values, we'll do plus 2. So do you understand how each described transformation results into change in the coordinate value? Now we'll apply this to the given coordinate point, which is minus 2, 16, right? And calculate. So minus 2, 16 will change to minus 2 times x0 is minus 2. Let me write down minus 2 here, right? Minus 1, that's the x value. The y value will be 3 times 16, okay, plus 2. So that results into minus 2 times minus 2 is plus 4 minus 1 is 3, so we get 3. The y value will be 3 times 16 is 48 plus 2 is 50. So that is the answer, right? So on the transformed curve, the original point minus 216 will be 350, and that is how you get it, right? So let's go through it once again. Vertically stretched by a factor of 3, that means 3 times the y value, the original y value. Reflected on y-axis means x value becomes negative. Horizontally stretched by a factor of 2, horizontally stretched affects the x value, it gets multiplied by 2. Translated 1 unit left, minus 1, 2 units up, plus 2. And once you substitute minus 2 and 16 for x and y respectively, you get its image point. You get the idea, right? So that is how it should be done. Now for practice, you can take another point. Let us say we have 3, right? 3 to the power of 4 is 81, right? So you could do with 3 and 81 and find their image point using similar transformations. I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn. Thank you for your time.